Welcome back, folks. I promised you we're going to look at mesh analysis using the other type of voltage supply that I introduced way back when. We've only worked one, maybe two problems with it, but with mesh analysis it becomes a pretty simple thing to add just one little extra step. And if you add this one little extra step, you don't have to be scared of dependent supplies. Some people this is a stumbling block for. Don't let it be a stumbling block for you. Because it's just one little extra bit of math that you need to do, and you already know how to do it. That, coupled with a little bit of algebra, you'll be in good shape. So I have this problem behind me right now, and let's take a look at it, because it's got a dependent supply. You just can't see it right now. It's behind my head. It's like right there. Right there. Okay. And I'm looking at this one. Now, there's 4 different combinations of dependent supplies you can work with, and this can cause some confusion for some people, but I'm always looking at the symbols on the inside. So the symbols on the inside tell me that this is a voltage source. So it's creating a voltage differential in the circuit. It's not doing anything with current. Don't get confused and look over here at what we call the control variable. And assume it's a voltage source. It's a voltage source because of the plus and the minus inside the diamond. Okay, this is our control variable, like that. Okay, and this tells me it's a voltage source. Okay, so sometimes we talk about these. I'm not going to draw them all out in this case, but I will mention it every time we have a different type of source. So this is a voltage-controlled voltage source. Okay, it's voltage-controlled because the control variable is a voltage, and it's a voltage source because it's got the plus and the minus on the inside. Okay, so this is a voltage-controlled voltage source, and you will see that abbreviation occasionally, mostly in textbooks, or if you're reading some literature. VCVS, voltage controlled voltage source. So the first letter comes from the control variable, and the second letter comes from the type of supply that it is. Okay, let's go work the problem. That's really what we're after, but I want you to be really clear on what type of supply it is, because if it was a current source, I'd have to write a KCL. Okay, and everything that I said, we count the number of current supplies, and that tells us how many KCLs we're going to write. I never said whether it was an independent or a dependent current supply, because it's both. We don't have that here. We will have that in another problem, I promise you that. Okay, let's clean all this up the old-fashioned method with Control-Z, so that I can work the problem from scratch here. Okay, so how many unknowns? And that doesn't change. We still identify our meshes. Okay, I1, I2. Okay, label our passive components with the passive sign convention. This one matches, which is kind of cool, so I'm just going to leave it there, but I am using that polarity inside the mesh there, plus and minus. Do the same thing for I2, plus, minus, plus, minus. Ooh, this one matches too. That's good. Everything else is active. This is an active component. It's not a passive component. It's going to add energy to the system. This is an active component as well. We're stuck with those polarities. Okay, now which order to do this in? I don't know what to tell you. I kind of want to get to the good stuff and tell you what the little extra step is. But let's go ahead and write the, well, I don't see a current supply. No current supplies, no KCLs. 2 unknowns means I do need 2 equations. So since we're doing mesh, they're going to be KVLs. Okay, so 0 KCLs because I have no current supplies, and 2 KVLs because I have 2 unknowns. So I need this little equation to work out. And that's my plan. Let's go write the KVL for I1 first. I think that one's going to look familiar, nothing tricky there if you've been following along with the videos. Let's see, we're going to start here. We're going to drop across the 6 ohm. And I1 is the only current, and it's flowing in the positive direction. We're going to drop across the 2 ohm. Again, I1 is the only current, and it's flowing in the positive direction. Here we're going to drop across the 4 ohm. I1 is in the positive direction. I2 is in the negative direction. Again, using the blue polarity to write that. And then from plus to minus, I'm going down across the 12, and that's equal to 0. Okay, so do a little bit of algebra. Okay, scroll up there, and let's see, we get negative 12I1 and plus 4I2 equals 12. And that one is ready for our system of equations. That one should feel familiar. Nothing crazy. Okay, if you've been paying attention to the videos and you've been practicing with the web work and all of those things, this one shouldn't give you too much trouble. If it does give you trouble, talk to me, come to class, and or go review the old videos. Let's do the red one. The red one, I2, has a little wrinkle in it, and it has a little wrinkle in it because of the presence of this dependent supply. So let's do some rearranging here. Maybe I should have left this one till the end since it's the tricky one, but let's bring that down here. Okay, so that we can look at what's going on with this circuit. Here's the extra step. This is what you need to do when you see a dependent supply in your circuit and you're trying to do mesh analysis. This KVL is going to not quite fit the format we want, right? We're writing the KVL for I2. We're going to go up across 12. We're going to go down across 4, and in this case it's I2 minus I1. We're going to go down across the 8, and we have I2, and we're going to go down across the 4 times I2, and now we're going from minus to plus, so we're going up, and we're going up 3Vx. Okay, in previous videos I said that we wanted our equations to be a bunch of constants and our unknown mesh currents and nothing else. And there's something in here that's a problem. That something is this right here. That is not a mesh current, and that is not a constant. So I've got to figure out how to get rid of it. And here's how you get rid of it. Vx. So if you have a dependent supply, somewhere in the circuit, that control variable needs to be labeled, and it is up here. So the Vx that this supply is dependent on is the voltage across R2 up here. We got to write one little equation, and then we got to make a substitution. But we know how to write that equation. It's the same way that I'm going to write the equation for V out. It's the same skill, right? All I'm saying is, how do I find Vx from my mesh currents? But my mesh current is still unknown. But we do the same thing. Okay, so we come down here and we say Vx. Oops, let's be consistent with our coloring here. Vx is equal to 2 ohms, and I1 goes in the positive direction according to the passive sign convention, and I2 doesn't touch it. So it's going to be 2 times 2 from the resistor and I1, positive I1. Okay, that's nice. Now I can take this, right, take that, and I can substitute it in there. Substitute. Make sure you don't screw up. Like I have this I have good habits, I have bad habits, I'll be honest. And one of my bad habits is I forget that gain sometimes. I'll just stick the 2i in there and I'll be like, I should have, it was 3 times 2i. So be careful with that. So beyond this, we just have a little algebra to do. Oh, I don't know if I gave myself enough room down there. Hey, KVL for I1. Let's see if we can make it work. So everything else is going to be the same here. Right, 12 minus 4, I2 minus I1, minus 8, I2 minus 4, I2 plus 3, and in here I'm going to put 2I1. Okay, and that's equal to 0. So with that little substitution, I got rid of the control variable, right? Nothing crazy. You know how to write the expression for Vx already, and then you just have to be careful with your algebra. Not a big deal. Hopefully not. You got to practice it, of course. All right, let's rearrange some stuff. So we've got a positive 4. Oh, we've got a positive 4 and a 6, right? Because this is 6 times 3 in front of I1. So that looks like it's going to be 10 I1. And in front of I2, we got negative 4, negative 8, and negative 4. So that's going to be negative 16 I2. I think that's all of that. And then we pull the 12 over to the right-hand side, and we get negative 12. Look at that. I think we're in pretty good shape. Look at those two equations. Okay. KVL for I2, KVL for I1. They're a bunch of constants, and they're the unknown mesh currents. So we're ready to put those in matrix form. Let me start it down here, and then I will solve it. I suggest you pull out your calculator or MATLAB or an abacus or a slide rule or whatever you have. I don't think you can do it on an abacus or a slide rule. I'd like to see you try, though. Practice with your tool. That's all I'm asking. Make sure that you get good at using the tools that you intend to use when it counts. I1, I2. Okay, and we got to solve it. If you haven't noticed, I got a haircut, so there's a little break in my videos. I got to find my calculator. Hold on, I got to pause. And I'm back with my trusty TI-85. Right? It's old, but it works, much like me. Okay. 10, negative 16, negative 12, negative 12, 4, 12. And from that, I get I1 is equal to negative 947.4 milliamps and 157.9 milliamps. So hopefully you got the same thing there out of your calculator, and you're getting a little confidence using your calculator. Okay, but we're finding V out. I don't know if I said that. No, I didn't. When I cut and paste these out of my notes, it gets lopped off. So find V out using mesh. Okay. V out. It's over there. It's right there. Come on. So we're going to find V out, and we can find V out. Let's see. I'll squeeze. I think I can squeeze it in over here. The same way we found Vx, right? That's the polarity for V out. I1 doesn't touch it. I2 goes in the positive direction according to the passive sign convention. So it's going to be 4 times I2. That's it. We got to calculate it. So it's going to be V out is equal to 4 times 157.9 milliamps. So let me give that a go on my calculator here. And we get V out is equal to 631.6 millivolts. Okay, what's your unit? Amps times ohms. This was in ohms. That was 4. Is that 4 ohms there? Okay, so not drastically different. Not drastically different. But when you see the diamond, look for the control variable and write an expression for it. Just like we did right here in orange. And then plug that in. A little bit of algebra, and you're back to a form that I'm hoping you're comfortable with by now. This was a voltage-controlled voltage supply. I think we'll mix it up and get a couple other different supplies in here and rearrange things and look at some examples like that. But I'm hoping what you're walking away from this video with is that you can do mesh analysis with dependent supplies. One little extra step. That's it. Okay? we got to get good at it, and getting good at something means we've got to practice. So stay tuned and good luck.